Now, for our continuous data sets, and as I said before, our continuous data sets have something slightly different going on. And that is that we're using integrals to work out the functions, because if it's a continuous function, what does that mean? That means that the graph has a shape. And if the graph has a shape, one interesting property that we find is that if we integrate, we can actually find the probability of it being between 2 points. So if we were trying to find the probability of, you know, so let's say we have heights of males or females, and we were trying to find the probability that the height of a random student selected will be between random student, random variable, what are we thinking? X. If we were trying to find the height, the chance that a random student selected was going to have a height between 1.6 and 1.8 meters. Well, if we were given a function that described this, we would integrate that function between 1.6 and 1.8 if it was in meters. And what we would find is actually the probability that we would actually find, you know, a student between those two sets. And it's a really interesting function. And then we get on properties is that they're integral between the maximum minimum bounds of the function, probability density function, is going to be 1. So when you're working out, if we're given a function, we can actually calculate the probability by integrating between 2 points, the 2 points that are given in a function. And in fact, if we look at the probability of one exact point, like 45.02222211 whatever, that's going to be 0. And that's because it's continuous. At any given point, it's 0. But if we go on an interval, we will actually have a value for the probability, whether that's large or small. And so we can actually find the integral using this formula. And what we can do is actually determine the mean or the expected value of a function of x for a probability density function, where x is our random variable. And so this top formula is just showing you the derivation. And whenever we see a sum sign, often it translates to an integral. And what I want you to know, I haven't put it in black here, so that's my mistake. I didn't mean to change them all, but it is in red here. I'll just, if it says on the page that if it's in the data booklet on the stats page, that means you don't need to memorize it. But it's still worth writing down just so you have an understanding of where we're actually getting these from. And, just the header and then the formula, that's sufficient just for now so that you've got a bit of an understanding, right? And then you'll consolidate that when you do it in class, questions, revision, etc. You'll be building on this, building on it until you get to your exam, and then you'll be ready to ace that exam and do as well as you possibly can, because your potential in this external exam is going to be 100%. And you have to believe that, because I certainly believe that, and you have to believe it yourself. Otherwise, you will be limiting how well you can do your potential on these exams. So the formula for the mean or the expected value, once again, the mean is the expected value. It's kind of like the middle value. It's a measure of central tendency. We also talk about median, but we'll talk about that later. Don't worry about that for now. We're just going to be talking about mean, and mean is also known as E of x, or the expected value, denoted by this symbol. It's called nu. Okay, so you can find this formula on the stats page in the data booklet. This formula, essentially, what we do is we integrate between the upper and lower bounds of the function, p of x being the function here, the probability density function, essentially. And when we integrate between these 2 points, we'll this is how we find the probability. However, to find the mean, we have to do this weird thing where we times it by x first. So p of x times x inside that integral in terms of d of x between the upper and lower bounds, which is often negative infinity and positive infinity. Sometimes we have multiple functions and then we break it up. This is going to be our formula, and you can find this in the data booklet. And you do get marks. There will be questions on that external that ask, hey, I want you, and on your internals as well, please find the mean or the expected value for this function. And by integrating between the upper and lower bounds and timesing it by x, as per this formula, you're going to get marks for that, and you will do well in your exams. You're going to pass your exams by just writing formulas from the data booklet and answering them by subbing in values. So P of X is the function, new is obviously mean, the expected value, and then we go from upper and lower value, just noting that we times it by X. That's what this formula is essentially saying, right? Okay, so this is the derivation of the expected value formula for continuous data sets. Now, you don't need to know this formula. I've put it here just for a bit of fun, and also, a little bit of an example, I guess. But you don't need to know it. For me, what I want you to know, like I got this here just to show. I know that there's super brainy maths people out there that are looking at this going, oh yeah, yeah, oh, so that's how it works. You don't need to know it. What I want you to know is that last line there, because that is in your data booklet. You should know when to apply that, which is if we've got a continuous data set, i.e. height, i.e., any kind of measurement, which isn't like a dollar value, it's a continuous data set. If you're asked to find the mean or the expected value, you are going to integrate between the lower and upper bound, whether that be negative infinity, positive infinity, or whatever, B and A. And what are you integrating? You're timesing X by the probability density function, by function of X, in, in terms of X. And that's in your data booklet, stats page, which is the second page of your data booklet. If you're ever in doubt in an exam, my recommendation is always to go straight to the data booklet, have a look, what are you actually dealing with, have a look, and usually you can figure it out from there. It can be a bit mathsy and the terminology can be a bit weird, but as long as you've done enough practice questions, you should be able to work it out. And it is all labeled, and there's, although they don't tell you what's what, in terms of the variables inside of an equation on your formula sheet, what they do is they tell you, okay, you've got this is for this problem, this they've got titles, which will really help you to work out what you need to do.